Problem 9. Cindy colors each region on the pattern either red, blue, or yellow. She colors regions that touches each other with different colors. She colors the outer ring region of the pattern red. How many regions does Cindy color red? These are our options. So let's use different colors to fill in this pattern. So we have outer one is red, as being said, so we cover it with the red. Now use different pen. We use blue next, and we cover it with blue. And let's see, use another pen, turn on the pen. I don't have any yellow, so my yellow is my green. So we use green now. We change pen to red now. Make it red, blue, and yellow as green, and red. So we use it alternatively. Now, question is, how many regions does Cindy color red? So red we can see 1, 2, and 3. So our answer is option C, 3. Problem 10. In 2020, there are 2 zeros. How many years in our centuries, 2001 to 2100 inclusive, have this feature? These are our options. So let's start step by step and see that in our first zone from 2001 to 2009, we have 2 zeros. So how many we have? We have 9 in here. Next step, we take it from 2009, 2010 to 2019. So how many has 2 zeros in here? 10, 20, 30, 40, 50, 2060, 2070, 2080, 2090, and again we have it as 9. Last, we have 2 zeros coming in to 100. That is 1. So we have 9 plus 9, 18, 18 plus 1, 19. So our answer is option E, 19. Problem 11. Loneki builds a fence using 1 meter long poles. The picture shows a 4 meter long fence. How many poles does Loneki needs to build a 10 meter long fence? These are our options. So let's start. What we have is we have 4 meter. That means how many we have? Let's count them. So we have 2 of this pole, and then we have 1, 2, 3, 4. So we have 4. And in 1 meter we have plus 4. Then we have 1, 2, 3, 4. Again plus 4. 2 meters. Then we have again plus 4 for 3 meters. And then for 4 meters we have this many already available. Now we'll add 4 more in here for 5 meters. Then 4 more here. That becomes 6 meters, 4 more, 7 meters, 4 more, 8 meters, 9 meters, and 10 meters. So this is how we make it 10 meters. Now we add it. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 4 times 10, 40, plus 2, 42, and gives us 42. So for 10 meter long fence, we have 42 meter. That's our answer, option E. Problem 12. In the picture below, every time the kangaroo jumps up to 7 steps, the rabbit hops down 3 steps. The stairway has 100 steps. On which step do they meet? These are our options. Let's break it down. We have kangaroo starts at bottom step 0 and jumps up 7 each time. So it jumps up a 7 multiple. The rabbit starts at the top, step 100, and hops down 3 steps each time. Now our goal is to figure out at which step they will meet on the stairway. So let's start. Let's start that a kangaroo jumps. How many jumps he makes, then a kangaroo does, and the rabbit. And then we could see where they meet. So at jump 0, kangaroo at 0, rabbit is at 100. They start at 1. They make a 1 jump. Kangaroo does the 7 multiplier law of jump, and rabbit does 97. Second jump, kangaroo 14, 94, 3, 21, 91. 4 jump, 28, and 91 minus 3, 88. 5 jumps, 35, 85. 6 jumps, 42, and 85 minus 3, 82. 7 jumps, 49, 79. 8 jumps, 56, 76. 7 nines are 63, 63, and 76 minus 3, 73. Getting close, yes. 10 jump, 70, 70. So they meet at jump 10. So our answer is option D, and they have to make 70. The kangaroo has to do 70, and rabbit has to do 70. And this is our answer. Problem 13. Emily wants to build a crown using these tokens. When 2 tokens share a side, the corresponding numbers match. 4 tokens have already been placed. Which number goes in the triangle marked with an X? So we have to find out what is a number X in here. So let's see the patterns going on here. So we see that we have 1 matches, and then 2, 3, 4, 5. And then 4 comes in, matches with here, and then 5, 1, 2, 3. 2 matches, 2, 3, 4, 5, 1. 5 matches here, and it comes 1, 2, and 3. 3 matches here. After 3 we have 4, 5, and 1. We matches 1 in here. 1 we have 2, 3, and 4. So the X number is 4, which is our answer, option D. Great job. We figured it out. The number in the X places 4. Let's move on to another puzzle. Problem 14. The sum of 3 numbers is 50. Karen subtracts a secret number from each of these 3 numbers. She gets 24, 13, and 7 as the results. Which one of the following is one of the original 3 numbers? These are our options. Our goal is to figure out which of these 3 numbers are the original numbers before Karen subtracted her secret numbers. Now let's call that secret number X. And then add this number to the first number, that is 24 plus X. Same second number, 13 plus X, 7 plus X. That means the sum of this number would be 50, and this is what it says. So 24 plus X, 13 plus X, 7 plus X. And let's solve this equation. So we have 3 X's here. Make it 3X, 24, 13, 7, and 50. We get 44 plus 3X equals to 50. Now we subtract 44 from both sides. So we get 3X and 6 here. We divide by 3 both sides. So we get X and 2. So our secret number is 2. Now let's add that secret number. So 24 plus 2 gives us 26. 13 plus 2 gives us 15. And 7 plus 2 gives us 9. So our numbers are 26, 15, and 9. And let's see our options. We have option A 9, B 11, 13, 17, 23. So this matches with our answer, option A. So our answer is option A 9. Problem 15. Part of a bathroom wall is shown in the picture. The tiles are arranged in a regular pattern, but some tiles have fallen off. How many of them were this shape? So we have to find a tile where that pattern fits in and see how many of them are missing. So let's start here. There are two fallen off, and that follows this path, so we have one missing here. Then we have three fallen off, and this follows this path, so this is one missing, and that's it. We move in here, we have 1, 2, 3, 4 fallen off. We follow this, it will be yellow, then we have 2 of dots, and then yellow one. Here we have again 4 fallen off, and that follows this pattern, so we have 1 in here and another one here, dot. If we follow this, then we have this one. Okay, so let's count 1, 2, 3, 4, 5, 6. So we have 6 of the tiles missing. So our answer is option C, 6. Problem 16. Several teams came to the summer kangaroo camp. Each team has either 5 or 6 members. There are 43 people in total. How many teams are at this camp? These are our options. We know there are 43 people in total. So each team has either 5 or 6 members. So let's start with all the 5 members. So we know that all the team will have at least 5 members. So since every team has 5 members, we divide 43 divided by 5 gives us 8 team and 3 remainder. So now we know we have 8 team with all 5 members. So we have 1, 2, 3, 4, 5, 6, 7, 8 with all 5 members. Then we add 1 in here, another team member in here, another in here. So all the 3 remaining members we fit it in. So now we have a team of 3 with 6 members, and the remaining is 5 members. So in total we have 8 team members. So our answer is option D. This wraps up part B of 9 to 16 questions from the 2020 Math Kangaroo for grade 3 and 4. Make sure to like, subscribe, and hit that bell so you never miss a new challenge. See you in the next problem solving adventure. Stay tuned for part C of 2020 Math Kangaroo for grade 3 and 4. And let me know which year you would like me to solve. Thank you.